Okay, hello all you crazy people out there. My name is Michael the Wizard Dragon, and let's break some things. Today we're going to be talking about exception handling. So this is GameMaker Studio 2.3. This has just come out, and it's added some new things. One of them is exception handling, or error handling as I believe they like to call it. I'm going to create a script. Let's call it string concatenate. Let's make the resource tree a little bit bigger so you can see it. There we go. Let's also make the size of the text a little bit bigger so that you can see it. Let's see, what is this going to do? I am going to do something that's going to cause an error, or potentially cause an error. Let's take two strings, value 1 and value 2, and add them together. Concatenate them, as it were. And you'll notice that this is very, very loose and informal and has a ton of ways that it could potentially break, but I will get to that later. First, let's go to the test object's draw event. Is there an instance of the test object in the room? There is. Getting a little ahead of ourselves, and let's do something with this string concatenate function. Let's draw text. I want to say 32, 32, except I always pick on those coordinates in the room, so let's go with something else. Let's go with 200, 200. We're going to draw the text a little bit towards the middle of the room. And let us string concatenate. Hello world is traditional. Fun fact, I almost never use hello world as my bootstrapping string. I almost always have the computer print out something goofy like I like doggos or something of that nature, but we will concatenate hello and world and call it a day. Okay, is that good? That is good. Let's run the game. Okay, the strings are jammed together with no space in between, but that's okay. Let us do this with something else. Let's say 200, 240. We'll space it out a little bit better. Let's go with a number and a number. Let's go with 10 and 50. I'm sure you all know what this is going to do, and I'm sure you all know what I want this to do, and I do not, in fact, want it to print out 60. So that makes sense, because we're just adding them together. We're just adding the values together, and the plus operator behaves differently based on whether or not you're using strings or real numbers. If you're trying to add strings, it'll concatenate them. If you're trying to add real numbers, it will, well, add them. Let's do another one. So that was unintended behavior, but it's not an error that would cause the game to break. Let's say hello and 50. Some programming languages would let you get away with this, GML will not. If you try and add a string and a real number together, it doesn't know what to do. If you want to add a string and a real number together, if you want to concatenate a string and a number, I should say, you need to first cast the number to a string. You would need to do something like this. The string function, casting a number to a string, is not the point of this video, although it will work. As you can see, those are misaligned. Let's go with 80. Again, not the point. So in previous versions of, I'm missing a parentheses there. In previous versions of GML, up until 2.3 on the 23rd of April 2020, you would have had to have done something like cast them both to strings, shut up phone, manually inside the string concatenate function. You could also potentially reject the input. There you can see we have 10 and 50 being jammed together to form 1050 instead of adding them to form 60. You could say if not is string, or if not is string, you could return error or something like that. I will get rid of this since we don't need it anymore. So that's going to show a couple errors. That's a little messy. You can use if statements to validate input as your form of error handling if you want. I am not a fan, especially now that GML has added a nice feature called try and catch. What is try and catch? If you've ever used a programming language besides GML, you probably already know what try and catch is. They will detect errors that happen in your code, and if an error arises, if it catches an error, as the verbiage goes, it will do something else. And you could use this to recover from situations that would otherwise break your program. For example, if for whatever reason you can't add these values together, you could say instead return could not concatenate the two values. And it doesn't matter what the error is, it doesn't matter if you're trying to add a string and a real number. You saw nothing. Tiny exception. Exception. Tiny caveat to what I just was trying to explain is that you can't actually return from inside try and catch and expect things to go flawlessly.
Hey.
All right, let's try it with this. Let's just put the return statement outside the try and catch. So as you can see, now instead of crashing the game, when I try and add a number to a string, instead of crashing or anything, it just instead returns the value could not concatenate the two values. Okay, that's pretty nice. And again, as I said, that will account for any error that could occur, not just an error caused by trying to add a string to a real number. You could do more with this. You'll notice the little e next to this catch statement. This is a structure. You don't have to call it e. You could call it whatever you want. You could call it error, or I don't know. You could call it something completely fun, like everything is terrible. It doesn't matter. It's just a variable name. And the phone. I have been getting a lot of notifications in the last couple of recordings. People are actually trying to talk to me, which is unusual. As I said, this is a structure that contains some information. If you were to F1 on the catch keyword, you could see a description of what can be found inside the structure. It is down here somewhere. Here it is. It contains a couple of variables: message, long message, script, and stack trace. If you don't know what a struct is, don't worry, I'll explain those some other times. For the time being, you can just think of them as proto-objects. You could get information out of them using the dot operator. So you could say everything is terrible.message, and this would append the message to the end of the warning that is returned when you say could not concatenate the two values. So if I were to run the game again, could not concatenate the two values, and the official error messages do add : execution error. If you've ever crashed GameMaker before, you've probably seen that. That's what happens when you try to add a string and a real number. There's also long message. I believe that is long with a capital M, camel case style. One of the only things in GML that is camel case, and I don't know why. And when I run the game now, it would produce a slightly longer error message. Okay, so this says error in action number 1 of the draw event, do add execution error, and then the stack trace. That's the classic error message that you would have seen in previous versions of GameMaker if you were to do something wrong. There's also the script. There's the script. This is just the script where the error arose. I believe it also gives you some extra information about it. Nope, just the script. GML script string concatenate. The script name plus the prefix for script or object or creation code or whatever. And then there is the call stack. Call stack, stack trace, stack trace. This is an array. This is the bottom half of the error message that you are probably familiar with seeing. If I were to convert that to a string, it would show the stack trace, which is the list of function calls, the list of script calls that has led up to this error. So you can see it originated in the draw event, line 5, which is over here. Line 5 in the draw event, and then it is a string concatenate the function line 6, or script I should say. Really function now, because they are functions. Line 6. This is the offending line that caused the error. That is a stack trace. I may talk in further detail about stack traces some other day, because they are useful for debugging errors. I should mention that this is an array rather than a string like the rest of the variables in the error struct are. So if you were to just try and concatenate the stack trace to the message, then you would have the exact same problem as before, except instead of do add execution, it's do add illegal array use, because you can't concatenate a a string and an array without first casting the array to a string explicitly with this. Okay, so that is exception handling. Again, useful, but maybe not the most useful, because in this specific case, you could just check is real or is string or any of those, and you wouldn't really need to worry about that. It gets better, though. You can use this for any error at all. So you can do things like trying to take the natural log of a negative number or of 0, because that would just break math. Try and take the arc sign of a value that is not within the bounds of -1 and +1. Any math error, if you were to try to do something like draw a non-existing sprite or create a non-existing object, you could use error handling to account for any bad behavior that might happen as a result of that, although you may want to actually track down why your game was trying to do that in the first place. In my mind, the place where this really shines is in dealing with buffers. So for those of you who don't know, they're like arrays, but they operate at a somewhat lower level. I'm going to plug a video that I did a couple months ago about buffers, in case anybody doesn't know how they work, and 2, I'm going to create a buffer. It's going to be of size 5. I think that sounds like a good size. The buffer type is going to be buffer fixed, because I don't really need it to do anything special, and the alignment is going to be 1. After that, let's write some information into the buffer. Nope, it is right. I'm just going to write a series of U8s. Let's go with 1. And count upwards. 2, 3, 4, 5. Okay. And then when we're done with that, we will seek back to the beginning of the buffer. Okay. Actually, let me do that when I'm going to actually access it. So now let's say instead of drawing text that is the result of string concatenate, I can't get it right. It's not peek and poke, it's read and write. Or in my case, it's read and write. You can peek and poke if you want to. I want to make a point with errors, with causing buffer errors. So phone. Let's do this a couple more times. Oh my god. I need to just like turn that thing off. It's in my pocket instead of on my desk right now, so I hope it's at least not that loud. Okay, so we're reading some values out of the buffer. That is 1, 2, 3, 4, and 5. Let's cause some errors. If I were to do this again, if I were to try to read a 6 value out of the buffer without jumping back to the beginning, error in action number 1, draw event for object object, attempting to read outside the buffer, returning 0. I don't know why that error says that, because as far as I know, it's never been true. You've never returned 0 after reading outside a buffer. It will always crash and not let you continue. So as it said, this is caused by trying to read outside the bounds of the buffer. And you could account for that. You could say if buffer tell buffer is greater than buffer get size buffer. We'll probably want to like draw something, some kind of warning message of that nature. That should be greater than or equals to, not just greater than. There we go. So now we can draw our little warning message here that says out of bounds. What if you want to verify every single axis of the buffer? Well, you could copy and paste this in front of every single time that you try to access the buffer. It's annoying. You don't want to do it. I'm not even going to continue because this is a nightmare. Nobody wants to do this. Nobody wants to manually check the whether you're inbounds, whether you're within the bounds of the buffer every single time you access it. And this is only 6 accesses of the buffer. Imagine if you're trying to actually like load stuff from a file or send something over a network and you've got dozens or hundreds or thousands of pieces of data that you want to get out of the buffer. Fun stuff. So I'm going to Control Z all of that. let's go back to what we had before. Exception handling gives us a much nicer way to do this. We can now wrap the entire thing.
Hey.
I'm just going to call it E this time because I don't feel like spelling out the entire thing. We can now wrap the entire block of code in a try catch, and then if anything bad happens, draw text 200. I'm going to put it a little bit farther down underneath the rest of them. Let's say 480. And we're going to do that. Let's also color it red. Just to make it stand out a little bit more. Red is a nice warning color. Association with fire or blood or whatever. I don't know exactly how red became stop, but okay, so we have read out 1, 2, 3, 4, and 5. We tried to read out 6, and then that causes an error, and the game informs us that we tried to read outside the buffer instead of crashing. And we can again append the message to it, and that might give us a little bit more information. What did it say? Okay, try to read outside the buffer, attempting to read outside the buffer, returning 0. So my own error text there is a little bit redundant, but it's there all the same. And this will work in all cases. If anything at all happens, as I said, you don't have to change anything. If I were to change the buffer size to 1, the error would happen on a different line, but it would be treated the exact same way. As you can see, only the first value gets read out, and then it causes it throws the error. If I were to, for any reason, decide to like change the value of buffer to a string or something, you obviously cannot read a buffer information out of a string. You can see try to read outside the buffer seek argument 1 incorrect type string expecting a number. And with that said, this out of bounds message isn't actually accurate, so I should probably delete it so it's not confusing. Anything that you can imagine could go wrong in this section of code or in any other section of code can be caught with a try catch. I should say there are some errors that you can't try catch. It's things that we'll call extenuating circumstances. If your game runs out of memory, or if your computer runs out of memory, or if God forbid your graphics card has a device driver failure and causes your entire computer to blue screen. Obviously, those are things that you can't recover from inside the program. I know in Java likes to differentiate between exceptions, which are things that you can try and catch, and errors, which are things that you can't try and catch. If your memory fails or if your RAM fails or something like that, that would be an error that you can't recover from for obvious reasons. I don't know if other computer languages make the same distinction. I'm just saying that because I know that somebody is going to ask that in the comments, and I want to get it cleared up front. Generally speaking, if those types of things were to happen, getting a little pop-up error on the game telling you that you can't read from outside the buffer is the least of your worries. Okay, that is exception handling. If you're anything like me and you're very glad to see try and catch finally arriving at last, you probably spent a good hour when you first got your hands on the update just causing different kinds of bad things to happen and wrapping them in try catch and having the game not crash outright because you just think it's that wonderful that it's finally here. One more thing to mention with try and catch is that there's an optional third keyword that you can add on to the end, which is finally. This is somewhat limited in its usefulness, but it does have its uses. Finally just means any code that you want to happen afterwards, after an error is detected, regardless of whether or not an error is detected. If you created a data structure and you want to do some things with the data structure, and if it causes an error, you still want the data structure to be deleted at the end, you would use the finally. You would probably want to use the finally block for that. More realistically, if you're using buffers, if you were to load a buffer from a file and you want to try catch reading information out of the buffer, and you want the buffer to be destroyed when you're done with it, regardless of whether or not it causes an error, you would probably put buffer delete inside the finally block instead. In a lot of cases, you could just ignore the finally block and put it at the end of the code, file. One, depending on how your program is structured, and B, depending on how much you like to please your computer science teachers by saying, I know what the finally block does. That may be something that you want to do. Let's see, anything else? I am looking through my, I am looking through my demo project, and that looks like all that I had to say about this. This is try catch. This is useful. Regarding the GameMaker 2.3 update, I've been telling people that, like, the other stuff is nice, the functions are nice, the structs are nice, the object-oriented programming is nice, but try catch is probably the one single thing that has the potential to save me the most trouble, because I do use buffers a lot, and being able to just hit the emergency eject button if something bad happens inside a buffer could save a lot of trouble. Anyway, that's it. There is one more thing with exception handling that I will probably talk about, but not now. I'll probably talk about this in the future, which is throw. Oh my god. ROW. There's a keyword called throw, which is for creating your own exceptions. That's not super exciting. I'll probably talk about that later. For now, my name is Michael the Wizard Dragon. I am going to try to make GameMaker videos, game dev videos, once or twice a week at least for the foreseeable future. If you happen to have found these useful, I have finally started a Patreon campaign page thing for these videos that you can have a look at in the video description. There's stuff on it. Regardless of that, go forth, be free of game crashing errors. Experience the joy that is not having your entire game break just when you, I don't know, try and reference a null pointer or something like that. I did not think that through. I will see you all later. Special thanks to Indie Punch and Zenith for supporting these videos. If you want your name in the credits and to force me to try and pronounce them out loud, head over to the Patreon page in the video description and join the fun. I am the all-time worst salesman ever.